Exposition, an LMC Experience original podcast. Hey, welcome to the Las Madonnas College Experience podcast Exposition. Today I'm here with my co-host T.
Hello.
And our special guest today, Scott Cabral.
Hi.
So, Scott Cabral, you're an astronomy professor here, right?
That's right, since 1989.
1989. All right. So our first question for you is, how did you get your start with astronomy?
Well, I got interested at the age of about 5 or 6. I don't know exactly why I liked astronomy, but when I was 5 or 6, I just got interested in it. I never lost that interest.
So what got you that interest in astronomy in particular?
I think it's the ideas. I mean, the idea that you can look out into space and see back in time, to me that's fascinating. And also the possibility of life on other planets, alien civilizations.
Really?
It captures my imagination. It's fascinating to me.
Oh, for sure. Where'd you go to college for astronomy, perhaps?
I went to Berkeley. I double majored in physics and astronomy. It's a double major because those are two different departments in two different buildings. And then I got my master's at SF State.
Oh,
Gotcha.
nice.
That's really cool.
I'm actually going to state in the fall, creative writing.
Oh, great.
So.
What's your major? Creative writing, you said. Good.
Awesome. That's incredible. All right, let's get into the more theoretical questions. You ready for this?
Oh, do my best.
All right, you want to ask your question first?
Sure. Okay. What do you think might be on the other side of a black hole, given that their primary source of energy is, the fact that there isn't any, technically, they're a void, complete inverse of what we'd normally consider. And given the fact that we don't have any comprehension of what they might be, what do you think, just in your professional or hypothetical?
Honestly, black holes are predicted by equations called the tensor equations from 1915, Einstein. And the equations predict the possibility of wormholes, where a black hole could form into a tunnel that opens up again somewhere else in our universe or in some other parallel universe. But the thing is, I think that just because the equation allows that solution, I don't know if that really happens. So if I had to guess, I'd say that black holes just have singularities at the center, which are points of zero size, infinite density, and they produce inescapable gravity.
Well, I did the lightest of research into this question, and I read most sources said that it does something like you'd be spaghettified if you went into one, like if a human went into one.
Yeah, they call it spaghettification.
What is that?
That's an actual technical term.
Really?
Yeah, when you get close to a black hole, as you get closer, the gravity increases in strength so much with each foot you go that you get pulled harder on one side of you, weaker on the other side, and the difference in pull just from one end of your body to the other end of your body pulls you into a string of atoms. They call that spaghettification.
That's very fascinating.
It's called tidal forces.
So, I mean, do you think we could ever put something into a black hole then? Would that even be within the realm of...
Yeah, well, things fall into black holes all the time. That's how they discover them. They see a black hole not by seeing the black hole itself, but by seeing the light emitted by the hot gas that's being sucked in, that's falling in.
I have a question. How are black holes formed?
Well, they're star corpses. They're one kind of star corpse. If a star starts out with a mass greater than 4 sun masses, then it collapses completely. Nothing can stop the collapse. And a star corpse shrinks all the way down to zero size and infinite density. That makes a zone of gravity around that point that cannot be escaped from, because escaping from that zone would require a speed greater than the speed of light.
That is very fascinating. I don't even know what I'd do with that information. But I want to do something with it.
Hey, do you gotta...
Black holes are pretty interesting.
No, they are. I mean, because the two things I had put was, like you said, like a wormhole of some sort, or time manipulation, because they're a point of, well, like you said, infinite mass, and yet there's nothing in it. So I was just, I was fascinated by the concept that there's technically anything on the other side of a black hole, if there's even an other side to most of them.
Yeah, the way I visualize it is a point of infinite density. It might have a mass of 10 sun masses or 100 sun masses, or 3 billion sun masses, something like that. And that empty zone, empty space around it, where gravity is so strong, it's like infinitely sticky quicksand. It's like infinitely sticky flypaper. Once you're in that zone, you're stuck forever. There's no way to get out because you can't go faster than light. Escape from a black hole requires faster than light speed, and that's impossible.
All right, I have a question. So I watched this movie called Interstellar one time, and there's something in there called Event Horizon. What is that?
The surface of a black hole, the point of no return, the edge where when you pass it, you're stuck, that's the event horizon. It's not a physical surface. It's just a boundary, kind of like the border between two towns.
Gotcha.
So if you're outside the event horizon, you're outside the black hole, and you can go fast enough to escape and get away. But once you're inside the event horizon, you're inside the black hole, and you can't go fast enough to escape. You're stuck there forever.
Interesting.
That's really interesting.
Would you like to?
Yeah, I would like to go to another song. Does dark matter exist? And what is dark matter in particular?
Yeah, well, anything you can't see is dark matter. And so there's ordinary dark matter, things like dust that's not lit by any light, cold, transparent, invisible gas, that's dark matter. Planets, there are 1 trillion planets in our galaxy outside our solar system. Those are all dark matter. So anything you can't see is dark matter. And there's ordinary dark matter that makes up 0.4% of the universe. But there's also exotic dark matter where they know it's there. They see its gravity acting. They see the effect of its presence, but they don't know what it is.
So
And that makes up about 23% of the universe.
So, like, what time period did they, like, come up with this idea of dark matter? I'm curious. Or, like, historically, where does this come from?
Well, I know that they first started studying it in the 40s and 50s because they saw stars moving in star clusters and in galaxies faster than they should. So they knew that there was more mass, that gravity was stronger than they thought it should be. So they knew that there was more mass there than they could see. So the mass they could not see was the dark matter.
So
And the funny thing is that most of the universe is dark matter. So astronomers are proud of what they've been able to see, but what they've been able to see is like 1/10 of what's out there.
So this exotic dark matter, the stuff that we genuinely don't know what it is, it could be hypothetically anything. Like,
Yeah, it could be some subatomic particle they haven't discovered yet. Could be some new kind of star, some new kind of matter. Maybe it's some kind of atom that hasn't been discovered yet.
that is fascinating.
It is really, really fascinating. Thank you for giving us information. It's really great. So I have a question about Mars now. What do you think about the new Artemis mission and continuing to landing on them? Oh. This is actually about the moon. I'm sorry.
It's a two-parter.
It's a two-parter. What do you think about the new Artemis mission that continue landing on the moon? Do you think it will lead to a long-term goal of landing to people on Mars? And what is the possibility of civilization on Mars for us?
Yeah, I'm not sure that we're going to be able to stop climate change. So I'm hoping that we can colonize the moon and colonize Mars. So anything that leads to that goal, I'm in favor of.
Well,
I'm just really pessimistic about our ability to reverse climate change. Although they say that late last year they did achieve nuclear fusion, ignition with fusion. If that turns out to be successful, that could produce totally non-polluting, infinite energy.
yeah, because
Unlimited energy.
Because that was the experiment where they created the energy from nothing. Technically speaking, they created it from there was no objective material that went into it. It was the fusion itself.
It's fusing subatomic particles and releasing energy in the process. It's basically the same thing that happens at the centers of stars, but in stars, the matter is squeezed together and forced to fuse by gravity. And in these accelerators, they do it by by magnetic fields and things like that. So we'll have to see where the fusion goes. If nuclear fusion turns out to be practical, that could solve the climate change problem, because we no longer rely on fossil fuel.
I mean, we wouldn't have.
But then that would cause all sorts of economic problems. Because what do you do with all the people who are displaced by losing their jobs?
No, that's both a really good point and also a very hard one to even really think about. Because on an economic level, I don't think things like oil and gas companies would even let that get out.
Yeah, there's a lot, yeah, that's the thing. Are they going to suppress it? Are politicians in states that rely on coal mining, are they going to allow it? It's a huge issue with lots of facets.
Yeah, no. I mean, even something
Very complicated.
even something like solar and wind energy is constantly suppressed. So, I mean, something like this, where it's like genuinely something that humanity can just make on its own with no external factor.
Yeah, the trouble with solar and wind powers is not totally reliable.
Yeah, exactly.
Yeah, for sure.
But nuclear fusion, that's like a coal burning plant. You just produce the energy as much as you want, whenever you want.
No, yeah, that's super useful. And as for the newest the relaunch of the Artemis program, kind of with the launch that they're going to try to do in the next couple of years, do you think that's a sign in the right direction when it comes to stuff like colonies on the moon and possibly exploration of Mars?
Yeah, and also with space programs like that, I'm in favor of them just for their own sake as employment projects. I'm in favor of the government taxing corporations and spending that money to put people to work. So the space program is an excellent, giant government spending jobs program. The military is a good way to put people to work. The Peace Corps is a good way to put people to work. And the space program is the same thing.
This actually, very similar to one of the questions we're going to actually ask you. It's we're going to ask you, this is a very hypothetical scenario, obviously. Hypothetically, how far along in space travel, if most of our tax money went to space travel?
How far along in space travel could you see us getting as a society if we started divesting, say, our military budget into space travel?
Yeah, it's hard to say. For example, look, if you've ever seen the movie 2001, the movie was actually a correct projection, because if they had continued at the pace they were in the 60s through 2001, they would have space stations
Really?
by 2001. But then people lost interest in the space program, so that never happened. So we could get to this 2001 scenario. We could get to that level of technology. I don't know how long it'll take, but it's possible.
I mean, with something like nuclear fusion that we've, just now been able to accomplish on our own as a species, I feel like that's, especially if it got the proper funding and the proper just labor into it, I feel like we could get there not fast, but relatively speaking, compared to where we might have been at in the 60s.
Yeah, China said they want to put people on Mars by 2050, and so we'll see how they go.
I remember seeing that. That's, if we can do it in
that's awesome.
Yeah, no, I don't care who does it at that point. It's just that's a step for mankind that I feel like no one should really be against. Honestly, it's just a good thing.
And it's just as a project. Think of all the people who will be employed by it.
Exactly, the engineers, the technicians. That's that's great.
I have a question that's not on this paper, but I just was really curious because I remember asking about you in your class last semester, because it was about how does infinity expand? We're in an infinite universe, right? So why does it expand, and can we quantify that we are expanding?
Well, think of a number line with integers marked off on it. 1, 2, 3, 4, 5. Now imagine taking every number and doubling it. And so every number becomes twice as big as it was before, and the whole number line expands twice as big, but it's still infinite. So it's like you take infinity, expand it, it's still infinity.
So would you say it's like, I don't know, in the hypothetical number line integers, would it just be like infinity squared or something like that?
It's the same basic, it's just bigger. It's the same number of integers, the same number line. The whole thing's just been stretched. And it was infinitely long before, and it's infinitely long after.
Interesting.
That's actually really fascinating.
Yeah, like even as like a visual example, like I'm trying to think of it, and it's
I remember there's this one idea of you think of a hotel that has an infinite amount of rooms, right? If you get and it's full, let's say it's full, right? Yeah. You get one person on the first one, you get everybody to go down, and there's still an infinite amount of room, which means there's more room for that one person, right?
If a new person arrives, all you do is ask everybody to move over one room.
Yeah.
You create a new room, but you still have an infinite number of rooms full.
Yeah.
No, that is just fascinating. I like that concept, and I like that that's just how it works.
The thing to remember, though, is that the universe may be infinite, but there's a difference between the entire universe, which is infinite, and the observable universe, which is finite. Because the universe has only been around for 13.8 billion years, so the observable universe around us is only 13.8 billion light years in radius. And so that means that we have our observable universe around us, but then there are an infinite number of other observable universes centered on other points. And since there are an infinite number of observable universes out there, there's every possible combination of atoms and quantum states and situations going on. Any arrangement of atoms that could possibly exist exists somewhere in one of those observable universes, centered on one of those points out there.
So you're telling me that there's a world out there where there's just Kool-Aid instead of water?
Yeah, exactly.
Oh, that's great. I mean, I love that. I love that idea. I love the idea of parallel, multiversal, just the concept of it. I think it's really fascinating, but also the fact that it is very much a real thing, like not tangibly to us as people, but also just, like scientifically speaking, that it can exist in such a capacity is it's both mind-boggling, but also very, very intriguing.
And that's a good point, that you have our universe with all of its infinite observable universes within it, but then there may be also separate parallel other universes in a multiverse. And that would explain the Big Bang, because where the energy of the Big Bang came from may have been our universe collided with some other parallel universe in the multiverse.
That's an interesting theory.
No, that is.
So you have our universe full of an infinite number of separate observable universes, and then other parallel universes in the multiverse.
My brain can't comprehend that. That's crazy.
There's the universe, the observable universes, and other parallel universes.
My brain honestly overloaded a planet full of Kool-Aid instead of water. At that point, I was like, yep, it's more science than I think I've done in my 2 years here.
What do you think about like constellations and like the history of constellations? I would like to talk about that with you, like about like I don't know, like how people created like different names for them and how we create new constellations now with like different names like microscopy and also what else is there?
Telescopium, microscopium, sextant's the sextant. Yeah, what I like about constellations is they're kind of like sociology or anthropology, because you can look at a culture's constellations and tell about the culture. I mean, for example, if they look at a bunch of stars and call it the scorpion, that's because that culture lived in the desert. But if another group calls the same group of stars the fishhook, that's because they live in the ocean and they fish a lot. So in a sense, studying constellations is like studying cultures. It's like anthropology.
That is a very good observation based off of constellations. I've never thought of it that way. But saying it aloud makes for like a lot of sense. The question that was attached to was, what do you think of the inconsistency people have with their understanding of astrology, especially like in a more contemporary context where people like to talk about, star signs when they're born and all that, despite the fact that scientifically speaking, those constellations have moved in relation to how we view, time in relation to months and years and all that. What do you think about that kind of misconception people have, and what would you say to someone who believes in astrology?
Yeah, I have nothing against it. I am pro-astrology. If someone's interested in astronomy, that's fine. I have nothing against that. Because for one thing, astronomy, which is scientific, and astrology are identical when it comes to observing. The observing part of astrology is the exact same as the observing part of astronomy. It's just the idea of what it means. Like in astronomy, you just observe things and learn about what's out there for real and physical laws. In astrology, they have this idea that the stars and planets can affect our lives. And they may be wrong, but if someone wants to believe that, that's fine. Because at least they're thinking about the stars.
That's a very fair point. Yeah.
And if someone's observing, keeping track of planet positions and star positions because they like astrology, well, an astronomer would do the same thing. That's all the same. The astrology knowledge about planet positions is the same as that knowledge in astronomy.
What do you think the possibility of there being extraterrestrial life is? or what's the likelihood of it?
Yeah, I agree with the NASA estimate from Frank Drake in 1960 that there should be about 10,000 detectable alien civilizations in our galaxy. That seems about right.
10,000. That's
It's a lot.
yeah.
I mean, with a trillion planets out there, no, I don't think any astronomer thinks that the Earth is the only place with life.
I don't think anyone thinks that to begin with. But also, yeah, no, 10,000 is just that's a big number. Like we can barely do with like a couple hundred countries.
Yeah.
Let alone 10,000 different species that all, function and look and act differently. That's an insane thing to think about. But also, as you said, NASA says it, and I usually agree with what they say. So
Yeah, I mean that idea of all those detectable alien civilizations. Well, with those civilizations being hundreds and thousands of trillions of miles away, it'll be a while before we interact with them.
So, do you think that with the stuff that they sent over with like that was the one like wasn't like the Voyager or something like that? It was some mission.
Yeah, whichever capsule it was that
Yeah.
was launched into deep space with all the
Information about what human civilization was
Yeah, the Pioneer 1 had a record on it, a gold record. It also had instructions etched on the record to tell aliens how to build a record player to play the record. But the record had recordings of people in all languages of the earth saying hello.
like. Really?
And then when the Pioneer 11 was launched, they had a plaque on it that showed a picture of a hydrogen molecule, instructions for how to find us in the galaxy, had a picture of our solar system, and had a picture of two humans next to the space probe itself for scale.
I mean, what do you think is the likelihood that will ever be found?
Or what is the ethics of that being found with other civilizations? How do we know that these aliens won't go and just like, I don't know.
Do war on us?
Well,
yeah.
that's why Stephen Hawking was against us broadcasting our presence. He was against what they call messaging extraterrestrial intelligence, because he thought that aliens would be like the Spanish in the New World. They'd conquer us and wipe us all out.
That's a very reasonable
point.
Yeah, that's a good
But it
point.
seems to me, though, that a civilization advanced enough to go from star to star would be enlightened enough not to conquer new people.
Well, I guess it depends on where you draw the line of like just material knowledge and I guess philosophical and ethical knowledge. I guess.
Yeah,
'cause-
that's a good point. Just because they're technically advanced doesn't mean they're morally advanced.
Yeah, because I mean that's how a lot of science fiction depicts alien
Yeah.
races or just humanity in space in general.
Yeah, they
but-
could be very much more advanced than us technically, but they could be just like the ancient Romans ethically.
Yeah,
Yeah,
exactly. I mean,
exactly.
I think the best representation of any spacefaring peoples is probably Star Trek, where it's like no one's got we don't we do space exploration for the sake of like protecting other planets and galaxies and such, but I feel like it's both a very utopian view, but also like you would just expect that if you have the ability to do that, then you would just be good and you would just do good with it. But
Yeah,
I guess-
well, if different cultures on Earth band together and cooperate for the mutual benefit, you'd expect different cultures from different planets in the galaxy to do the same thing.
Mm-hmm.
But I guess it also depends on if they even have an understanding of what culture might be. If they're even capable of like comprehending that, even while being able to comprehend something like building a spaceship.
Yeah.
It's a fascinating thought.
Yeah, and plus on Star Trek, the aliens were played by human actors in fancy costumes. In reality, when they discover real life out there, who knows what it'll be like?
Mm-hmm.
I mean, it could be disembodied electrical energy or something we can't even imagine right now.
Have you seen the movie Nope?
Oh, I think I saw that.
It's
Yeah.
like something like that, like where it's like just something that's like so unimaginable and like abstract that's crazy.
Yeah, that's the one where at the end, what you thought was the spaceship was actually the alien itself.
Yeah.
Mhm.
Yeah, that's a good. I think I remember that.
Yeah, and I mean, if we ever encountered something like that in space, like, would we even know what to do with it? Would we just like what's the human response to something of
Yeah,
that scale?
Yeah, they have protocols, and the first step is just to announce it to the world.
Mhm.
And sociologists have done studies, and they say that if it was announced that there is an alien civilization out there, people might be interested, but it wouldn't disrupt society.
Really?
I mean,
But there is there's like a United Nations protocol for step-by-step things to do to announce the discovery to the world.
no, again, I'm not surprised, but I'm also like learning that that's a thing.
Yeah, and again, when they discover that alien civilization, it's going to be hundreds or thousands of trillions of miles away.
Oh, for sure.
So there's not going to be direct contact.
Well, I guess, and I mean, it's contingent on them being that far away. But if they're, as we said earlier, someone who's capable of traversing stars, then I mean, there's, I guess, there's an infinite possibility of an alien showing up on Earth's doorstep, and also the infinite possibility of them never doing that. So, I guess it's all just a big guessing game at that point.
Yeah, that's the thing, is that the Earth and the Sun are so average, so ordinary, so nondescript, that an alien that was traveling through the galaxy would pass us by. They wouldn't even notice us.
Really?
So that's why I don't think we've been visited, because no one would ever even, they would pass us by and not even know that we were here.
That's again a very good point, and one that I agree with. Because I mean, from space, even the pictures we have of our own galaxy and solar system, they're not anything different or unique. You look out into the cosmos, and there are plenty other places that look, just on the basis of what they look like from millions of light years away, they look way more interesting compared to our cozy little home here.
Yeah, I mean, to us, our Earth and our solar system are the center of our reality. But to other aliens, we're nothing. We just blend in. We're not even worth noticing.
Yeah.
All right. I have a very, very controversial question to ask you. Why you be crapping on Pluto like that? Why is that not a planet no more? That's my favorite planet. The heck?
Pluto's a planet. It's a minor planet. It's not a major planet. It's a minor planet, but it is a planet. It's a dwarf planet, but it's a planet. Yeah. As far as, that idea that Pluto's not a planet, that came from an invalid vote in 2006 in Prague, in the Czech Republic, where the people who organized a conference told astronomers that they'd be able to vote officially on what the definition of a planet would be.
Mm-hmm.
And then the vote was supposed to happen on Saturday. They canceled the vote on Friday, so the astronomers all left, except for 300, and then they held the vote after all on Sunday. So that vote that said that Pluto's not a planet, to me that's an invalid vote.
Because
Based on canceling the vote on Friday, waiting till everybody leaves, and then having the vote after all on Sunday.
wow, I did not know. And that's when the classification of Pluto changed? Like the classification from it being a conventional planet?
Yeah, the vote was whether a dwarf planet is a planet or not.
Yeah.
And all the astronomers that I've ever heard of say that dwarf planets are planets. I mean, in astronomy, a dwarf star is a star. A dwarf galaxy is a galaxy. So a dwarf planet is a planet.
Yeah, it just means that they're smaller. Yeah.
Yeah.
Oh, that's very interesting. I didn't know that was what happened. And I think that's it. Do you have anything else?
Is there anything else you would like to tell our audience, Scott?
I hope this podcast is a big success.
Oh, thank you so much. We
Thank you.
appreciate it. All right, for my homies at home, I gotta say thank you for listening in, and I have a few shout outs to give. I want to thank Maxwell for supporting this podcast as well. She said she's supportive of this. She's our vice president here, and I also wanted to. I was told by Student Life to also shout out for the creation of Astronomy Club. They want to have a club for astronomy around here, and it would be nice if someone would like to start it. Would you say you would? Would you advise that, Cabral?
Yeah, you might want to contact Katie also, Katie Berryhill.
Yes. And that is all. Thank you for listening. Bye.